everyone. I will talk about my final project. I choose the Kaggle competition for my individual final project, and you can see here for the public leaderboard I ranked the third place, and for the private leaderboard I ranked the third place as well. Okay, so next I will talk about my codes for the project briefly. So at the first glance of this project, I'm thinking to use the NLTK method that we learned in class, and there are major two common stemming algorithm, Porter's and Snowball stemming algorithms, and I tried both. That's why I had two Jupyter notebooks, and because the one with Snowball stemming algorithms didn't have performs better than the Porter's algorithm. So generally, I will discuss only on this notebooks on the Porter's stemming algorithms. So this one is only my intermediate results. Okay, so let's go through the codes briefly. First, I just loading all those data set, the training test, product description and attributes, and then what I do is grouping the attributes together, because for the attribute tables, for one product they may have so many lines, so they have multiple lines. So I use a merge to combine them together, so then I can have this merge table for each product have one single line of the attribute description, and then have two functions created. One is the major stemmer function that removes the non-alphanumeric characters first. So it removes some hyphens or the other characters rather than alphabetical and numeric letters, and then applying the Porter stemmer to the strings after doing case folding. The other one is to to find the common words for the two strings, which I use this for some basic features I create. And then here is I combine all those tables together, and then I just doing the stemming for all the string variables in the table first, and then I obtain the table after doing the stemming. So it looks like this one. Then I create some features that may be useful in regressions or my modeling process. I create the length of each of those informations, the title, description, and value. And also I create the query in title, in description, in value, that is how many of the common words are showing in search term, and the product information. And also I create the binary variable for whether the last keyword in this search term is inside the product information, like all the three information. Because the reason why I create this, because it may be used for, since the last word in the search term usually be the key, or the key ones what I have to use. And then I compute cosine similarities, dice similarity, and Jacobi similarities, just using the informations what I have. So I put the products and the search terms together. So I put all this four together. Then I can use this combined information to compute the document term matrix. The easiest way to do this is that for sklearn there's a count vectorizer function, so I just import this. They also have other like the TF-IDF vectorizer. This one is a normalized version. I use the count vectorizer that is non-normalized version, but that is good for this because we can use that to find the counts for all of the document and the queries, found the term counts. So for after doing this, I can easily compute the cosine district similarities, and then I can do a query expansion to compute this similarity again. One problem or one limitation of my project is if I doing the normalized association matrix inside the query expansion, then it takes so long. So the computation power of my laptop cannot do this. That's the reason why I just use the non-normalized association matrix to do the query expansion and then compute the similarities. So there may be a problem, but I think I only can improve this later on. And also, I create another 3 similarity features. Just use some high IDFs. So I ignore the terms that appear less than 10 documents, and then within that I can create the other 3 features. So then I have 9 key features with some basic features I created to fit models. Generally, I use the two supervising learning methods. So one is the XGBoost, which is most powerful ones, and then the other one is random forest. I doing some hyperparameter tuning for both of them. So you can see this are some hyperparameter tuning, and I can achieve my summation scores because I save the submissions CSV files, submit on the Kaggle, I can get the scores. For the conclusion, I can find that XGBoost has a better or smaller RSME scores, so I'll go for that one.